All right, welcome back, students. Right now I'm going to be showing you and teaching you about the law of sines. First, what we're going to do is go through the proof of the law of sines, where the law of sines comes from. Now, the law of sines is a relationship between angles and sides that can work with any triangle. However, prior to this, the only time you've been able to use the law of sine or use sine, cosine, any of those has been if you've had a right triangle. Now, the law we will learn today you can use on any triangle, but in order to get at it and figure out what it is, we need to start by creating a right triangle. So my first step is I'm going to go from B and I'm going to create an altitude. Now an altitude just goes from a vertex down to a side and creates a 90-degree angle. So now I've got two 90-degree angles, or two 90-degree triangles. We've got this one on the left and this one on the right. And now that I've got that, next thing I'm going to do is label my altitude, and I'm just going to go ahead and call it K. Now, using this triangle that we now have, I'm going to use sine, which will usually give us the opposite over the hypotenuse on these two angles that we have, angle A and angle C. So if I do sine of angle A, then the opposite of A is going to be K, and the hypotenuse of this triangle on the left would be C. So sine of A should equal K over C. Sine of C, well, opposite of C is also K. And then the hypotenuse of this triangle is A. Now the fact that both of those use K is to our advantage. And what I'm going to do first with this is go ahead and solve for K and get K alone. So on this first one, if I multiply both sides by C, that should eliminate that and we'll be left with K. On this side, I'll multiply both sides by A. And then we end up with these equations that are sine of angle A, C sine of angle A is equal to K, and A sine of C is equal to K. Now, what I can do here is use what's called the transitive property of equality. Put simply, if A is equal to B and B is equal to C, then A must also equal C. So because both of these equal the same letter, both of them equal K, they should both also be equal to each other. So C sine of A is equal to A sine of C. Now, we're pretty much there. We've created this relationship, and notice we no longer have K. This relationship no longer is dependent upon using that right angle. It can now be used for any triangle. One thing I'm going to do is just rearrange some of these to group them with similar letters. So I'm going to divide both sides by AC. So on this side, the A's will eliminate. On this side, the C's will eliminate, which leaves me with the sine of A. Oops. Went a little ski-wampus there. The sine of A over A is equal to the sine of C over C. And this is what we would call the law of sines. This is the equation. Now, if we were to do the same thing above, only this time we created another vertex, but rather than on B, maybe we put it on A or put it on C, and we'd be able to see that this is also equal to the sine of B over B. Now, these capital letters represent the angles, And the lowercase letters are representing the opposite side. Okay, so this relationship right here, that if I take sine of an angle divided by the opposite side, it should be equal to the sine of another angle divided by its opposite side. We can use this relationship to find missing angles or missing sides. There is one other way to write this relationship. And I want to quickly demonstrate how the thought process works. So if 3/4 is the same as 6/8, so we know this is true. What if I flipped that fraction? 4/3, what is it the same as? 8/6. Now, that is also true. So if I flip both fractions, the equality remains true. So they both remain equal so long as I flip both fractions. So this same statement that we already have written here could be rewritten as A over sine of A is equal to C over sine of C, which could be equal to B over sine of B. It's the same exact relationship, just rewritten. And depending on the problem we get, we may want to write it in a different form. Now, in the next examples I'm going to show, hopefully I can illustrate well when we want to use this relationship up top in black and when we want to use the relationship below in red. So here are two problems that will use the law of sines. Now remember, it was always an angle with its opposite side. So that right there is going to create the relationship, or start us off with the sine of 86 divided by the opposite side was 20. Now notice in this problem we are looking for the measure of angle C. So I'm looking for C right here. Now if I go straight across, I see that its opposite side is a 10. So this would create on this side sine of C divided by its opposite side, which is a 10. Right here, I've now set up my law of sines by mixing opposite angles with their sides and dividing them. Now, what I need to do is get C alone. So the first thing I'm noticing is this divided by 10. I'll go ahead and multiply both sides by 10 to deal with that. And we will have 10 sine of 86 over 20, which will then be equal to sine of C. Next, in order to get rid of sine, we're going to need to use the inverse of sine. So the inverse of sine is written like this: sine with a -1 that kind of looks like an exponent. It is not an exponent, it is just there to signify that this is the opposite of a sine. Now if I do the sine inverse to both sides, those two will eliminate. The sine inverse does a sine backwards. In the same way that division does multiplication backwards, sine inverse does sine backwards, and they will undo each other. So after that step, we could be left with just C being equal to the sine inverse of 10 sine of 86 all over 20. So our next challenge is finding the answer to that and being able to calculate that. So what I'm going to do is open up desmos.com. And that's the resource we're going to use right now to do this. So just go to desmos.com, open up the graphing calculator. First, I need this sine inverse. So if I come down here to the bottom left, show the keypad, go to functions, there's the sine inverse. And now, because what's inside is a fraction, first thing I'm going to do is press the divide key, and it automatically makes that for me. So I'm going to type in 10, and you don't always have to click the sine key. You can also just type sine out, and it will know exactly what it's doing with that. So 10 sine of 86 divided by 20. Now there is one problem before we get our answer. Notice, I was calculating angle C, and this says that my angle is a negative 0.47. So clearly this is wrong. No way we get a negative. One more thing you need to do. Click over here at Graph Settings on the wrench. Notice it defaults to radians, but when we're dealing with triangles, it gave us degrees. So I need to switch that to degrees, and you'll notice it changed my answer for me. So this, so C should be approximately 29.9, or not feet, this was an angle, so that should be 29.9 degrees. All right, so there's our first problem. This next one is different in that this time I'm looking for the side. I am looking for the side AC, so going from A to the C. So I am looking for that side. So if I begin setting up my problem using that, I want to know that side, and the opposite angle is B, which we know to be a 40. So if the angle is called B, I'm going to call this side little b. So let's go ahead and set that up so that the sine of 40 degrees is then divided by the side B. All right, so we got that one going across. Next, I need to find some other relationship I can do. Well, I'm given this side of 38, and in fact, that's the only side I'm given. So I definitely need to work with that. Trouble is, working with that 38, I don't know what angle C is yet. So let's take a quick look. We do notice that we're given B and A. Now, all of the angles in a triangle should add up to 180. So if I want to find this angle C, I can just do 180, subtracting those two angles, and I'll get 128. So now I know that angle C is 128, and it goes with that 38. So sine of 128 divided by 38. Here's my challenge. I can now solve for B, but think about all the work that's going to entail. First, to get it out of the denominator, I got to multiply both sides by B. Then, when B is over here, I've got to get rid of this fraction. So I'll have to multiply by 38, and then I'll have to divide by sine of 128. So there's 3 steps just to get to B. Or, if we want to do this in a much simpler fashion, we can rewrite that, that fraction the way I showed you before. I'm going to now switch it to be B over sine of 40, which is equal to, and we flip the other one as well, 38 over sine of 128. So now that I've got this, in order to get B alone, there's only one step. Multiply by sine of 40. So when you are working, trying to find a side, flip the fractions like this. All right, so now I'm going to go ahead and do that. So it's multiply by sine of 40, multiply by sine of 40, and we then get b is equal to 38 sine of 40 all over sine of 128. And then when we put it into the calculator, we should be able to get the approximate answer. So I'm going to go ahead and do or actually first notice it's a big fraction. I'm going to press my divide key. 38 sine of 40 all over sine of 128. So rounding that up to the nearest tenth, that actually puts us at approximately 31 inches, since that's what they were measuring with there. Okay, so that's how to use law of sines to solve either for an angle or for a side, and how to use the whole 180 rule to find a missing angle. Now I'm going to go ahead and put Desmos off to the side. I'm still going to make some calculations, but I'm not going to show Desmos each time. Next thing we need to talk about is finding the area of a triangle. So area of a triangle is always 1/2 base times height. So in this first triangle, we have 1/2 of the base, which is 6, and the height, which is 4.5. Got all numbers. I can type that into Desmos, and I'm going to get 13.5. It's an area, so this was in kilometers, so the answer is in kilometers squared. If we do that right here, area is equal to 1/2 of the base times the height, which should be 1/2 times 5 times 3.7, which is then going to be equal to 9.25 feet squared. All right, little review on finding area of a triangle. In these triangles, I don't know the height. Now the height is always at a 90 degrees, so great, we've got a 90-degree angle to work with. So in order to find this height, here's what I'm going to do. I'm going to take the sine of that angle. So sine of 46, and it should be equal to the opposite, which is our height, over the hypotenuse. The hypotenuse of this right triangle is going to be the 11. And now to figure out the height, I just need to multiply both sides by 11. So then my height would be equal to, we could type that into Desmos, and it is approximately 7.9 kilometers. Okay, let's do that again. Once again, we don't know the height, so we can't figure out the area without that. So I'm going to set up this sine equation to find it. Sine of 47 is going to be equal to the opposite, which is going to be the height, over the hypotenuse. Hypotenuse of this triangle will be that 5.4. Okay, to get h alone, I just need to multiply both sides by 5.4. And then we have 5.4 sine of 47 is equal to the height, which is going to be approximately 3.9 kilometers. Okay, now notice how we did the same thing in both of these. We set up a sine equation. Our height was going to be opposite of the angle, and then we just needed to multiply by whatever the hypotenuse was. And that right there always gave us the height. Now in this following triangle, we don't know any sides, any angles, but we're going to create that same relationship. And we're going to write out an equation for the area. So I'm going to start off with, first I want to find the height h. So if I take the sine of angle C, well, opposite of angle C is going to be the height, and then my hypotenuse for this right triangle on the left is B. Once again, I only want the height, so I'm going to go ahead and multiply both sides by B, which would then give me B sine of C is equal to the height. So now in order for us to get the equation for the area of that triangle, I now know what the height is. The height is B sine C. So the area of a triangle is 1/2 times by the base. The base is A. And then 1/2 the base times the height. Height is B sine of C. Now, it's important to note where those came from. Notice that A and B are two sides that are touching, and C is that angle in between them. So that's how we figure this out. In these next problems, I've got that side for my base, which means that side's going to be the B in our equation, and C will be the angle in between them. So I set this up as the area is equal to 1/2, and my base is a 10. And then we've got to find the height. The B is 11, and we're going to have sine of 46, which comes to approximately 39.6 kilometers squared. All right, let's do it again. First, I've got my base. That's going to be A from that equation above. Then we've got this side that helps make our angle, so that's going to be my B, and my C will be the actual angle formed by those two. So area is equal to 1/2 of the A times by the B times by sine of the angle in between them. And that's going to equal approximately 9.9. All right, one more. So this one does look a bit different. They didn't even draw in an altitude for us, but that's okay. Similar thing. There's going to be our A. There's our B. These two lines form to create the angle that we'll use for C. So the area is going to be equal to 1/2 of 14 times by the 15 times by sine of 114, which will equal approximately 95.9 kilometers squared. I hope this helps out with the assignment. Good luck.